This is chapter 9.4, quick review, numbers 1 through 10. And this section of the book, section 9.4, has to do with sequences. And so these exercises are really preliminary to working in sequences and using the formulas and so forth. And so what we can do for problems 1 and 2, you evaluate each expression when a equals 3, d equals 4, and n equals 5. And the way to do this is simply to replace. And so we're going to say if a is 3, we're going to replace a with 3 plus, and n is 5. And we have minus, bring down the minus 1. And d is 4. And so now really it's about using the order of operations properly. The first thing we'll do is inside parentheses we'll bring down the 3, and we're going to have 5 minus 1 is 4 times 4, and using order of operations we have 3 plus 4 times 4, which is 16, and so our answer is 19. And we're going to go on to the next odd number problem, which is 3. But to do that, and here we have exercise 3-4, evaluate each expression when a equals 5, r equals 4, and n equals 3. And we have a times r to the n minus 1 power. And so what we're going to do for that, I'm going to show you a calculator storage method. So a equals 5. So I'm going to go 5 storage a. So a is stored to 5. R equals 4. So we're going to go to 4. Control of R's R. And n equals 3, I believe. Let's see that. N equals 3, yes. So 3 storage n. Okay, n. And we have that. We have 5, 4, and 3 stored for a, r, and n respectively. If we go back to the equation, we have a times r to the power of n minus 1. So we'll put that in. A times r to the power of, we'll have n minus, just be sure I'm going to put this in parentheses, n minus 1, and we just press enter, we get 80. So that's what we have, that's what the book says it is, equals 80. So this was using the calculator. The store, sometimes the calculator can help avoid errors. We could check it out by hand. A is 5, right? 5 times r times 4 to the power of n. Well, n minus 1 is 3 minus 1, so we got 5 times 4 squared equals 5 times 16, which equals 80. Yeah, check. Okay. Check. Now on to number 5. In exercises 5 through 10, find a sub 10. Basically, you have a sub k equals, and 5, a sub k equals k over k plus 1. So we can say a sub 10 is equal to 10 over 10 plus 1. So a sub 10 equals the fraction 10/11. There we have our answer. On to number 7. A sub k equals 5 times 2 to the power of k minus 1. So here we have k is equal to 10, right? So therefore, what is k minus 1? K minus 1 is going to be equal to 9. And so if we'll say a to the power of a sub, I say to the power a sub 10 is equal to 5 times 2 to the power of 9. Okay, and we could do this in our head if we wanted to. I don't feel like today. Say a sub 10 is equal to 5 times 2 to the power of 9. So we get 2,560. There it is, a sub 10. Next we go to next on our problem 9. A sub k equals 32 minus a sub k minus 1 and a sub 9 equals 17. Well, here a sub k, we want to find a sub 10, right, equals a sub 10. So therefore, put dot dot dot, a sub k minus 1 is equal to a sub 9. Does that make sense? It should. And here we are given that a sub 9 and see the relationship a sub k minus 1 and a sub 9, they're the same thing. So this 17 we can just replace this a sub k minus 1. So therefore a sub 10 is equal to 32 minus what we replaced a sub k minus 1 with, which is 17. I'll just draw this right here. So therefore a sub 10 is equal to 32 minus 17, which equals 15. And using these for sequence and series, using these formulas, we need to be able to replace the term numbers and kind of figure out where they are. So it's really a good little preliminary exercise. Good luck on the rest of these even number problems and the rest of chapter 9.4, which is kind of like skip counting, skip multiplying, and so forth. I say to you, good luck, and thank you for viewing.